Good day, viewers all over the world. Today we want to look at the solution to first order differential equation. So we'll be starting with the first one, which is called this separable first order differential equation, that is separable variable. That is, if you are given any first order differential equation, if at the end of the day you are able to separate the variables, then you are expected to use the separable variable. So the separable first order differential equation. Let's look at this example 1, where we are to solve x dx minus y squared dy equal to 0. So what do we do here? You realize that this is x beside dx, then y squared beside dy. So we can say solution. You just say x dx will now be equal to, we can transfer this to the other side, y squared dy. Then we introduce integral sign to both sides. If we integrate x, we are going to have x squared all over 2 will be equal to, if you integrate y, we are going to have y cubed all over 3, then plus arbitrary constant. We have to put an arbitrary constant at one of the sides. Then at the end of the day, I can bring in this value. Okay, I can transfer minus it to this. That is, I will say y cubed all over 3 will be equal to s squared all over 2 minus c. That is, if c should come to this side, then what can I do here? At this point, what can I do? I might decide to multiply through by 3. If I multiply through by 3 here, I'm going to have y cubed here, which will be equal to 3s squared all over 2 minus 3c. Now, where c is an arbitrary constant. Okay, c is just an arbitrary constant. So I can say let maybe a to be equal to 3c, so that y cubed can be equal to 3s squared all over 2 minus a. It's still the same thing. Where c is arbitrary constant, so it's still the same thing. I can decide to use any constant to represent that. Then how do I get the value of y? Y can be equal to, I can take the cube root of both sides. If I take the cube root of both sides, then y will now be equal to 3s squared all over 2 minus a raised to power 1 over 3. Then that will be the final answer that we are going to get there. Okay, that will be the final answer that we are going to get there. So under first order differential equation, if you are given any first differential equation in first order, just look at the question very well. If it is possible to separate x with respect to dx, then y with respect to dy, then you should know that we are going to apply separable approach to that. So we take another question. Under separable first order differential equation. Let's take another question. So this is what you are going to have. You can stop here. Even if you like, I might try to stop at this point. So that's what you are going to have. So let's take another question. We take another question. Let's take another question under separable variable. Let's take another question. And in this case now, we have to solve y tan x dy dx is equal to 4 plus y squared sec squared x. This is what we are given. So if you have this type of first order differential equation, how do we get the solution? Just look at it very well. Is it possible to separate s with dx, then y with dy? Just look at it very well. Is it possible to separate that? And I think the answer is yes. Because if we divide through by this, I can say this can be, let's divide through by 4 plus y squared, so that I'm going to have y all over 4 plus y squared here, tan x dy will be equal to, here I will just have sec square x. Okay, sec square x dx. So at this point also, I can also divide through. Let's divide through again by tan x. Okay, tan x can take care of tan x here, so that we have y. We are going to have y all over 4 plus y squared dy over dx to be equal to sec square x all over tan x Then this ds can actually go. Ds can come to this side. Okay, I can multiply through by dx. If I multiply through by ds, finally I'm going to have y all over 4 plus y squared dy will be equal to sec squared x all over tan x dx. If I multiply through by dx, that's what I'm going to have. So we have been able to separate this now. Y with respect to dy, then x with respect to ds. So we have been able to separate this. Since we have been able to separate this, then we can go ahead and apply separable. So we have been able to separate this. Once we are able to separate it, then what is required is that we just introduce integral sign. Then we get an answer. So I will introduce integral sign here. I will introduce integral sign here. So how do we integrate this? So at the right hand side, what do we do? At both sides, we are going to integrate using integration by substitution. So using integration by substitution, what will happen? I will let everything here, the denominator here, I will reset it as u. This is what I'm trying to say. The first one here, where I have integral, I want to change it. I will say let u equal to 4 plus y squared, so that the u, the y will be equal to 2y. Then I want to make the y subject to the formula. The y, 2y dy will be equal to du. Then dy will be equal to du all over 2y. That's what I'm going to get here. So this will now be y all over, instead of 4 plus y squared, I'll change this to u. Then multiply by, instead of dy, I'm going to change this to du over 2u. That's what I'm going to have at the left hand side. Integral, I will do the same thing at the left hand side. What will I do at left hand side? I will say let u is equal to tan x, so that du dx will be equal to sec square x. Then I want to make ds the subject of formula. Ds will now be du all over sec square x. So that's what we are going to get there. It's going to be du all over sec square x. So this right hand side now, I will have sec square x all over, instead of tan x, I'm going to change it to u. Instead of tan, I'm going to change it to u. Then multiply by, instead of the x, I'm going to have du multiplied by sec square x. So for us to be able to integrate these two now, we're going to apply integration by substitution. That's what we have applied there. So there will be some cancellation. This will take care of this. So at the end of the day, I'm going to have half integral 1 all over u du will not be equal to this. We take care of this. I'm going to have integral 1 all over u du at the right hand side. So if I do that, I'm going to get from there now. From there, I'm going to get half. What is the integral of 1 over du? That will be in u. That's what I'm going to get. Will be equal to, this will be in u. But I try to use u, but maybe I should change this to v, so that there won't be confusion. Let's change this to v. Let me change this to v, so that there won't be any confusion. So let me change this to v, so that I have v here. Let's change it to v. Okay, so that I have in v here. So I have in v there. I have in v there plus arbitrary constant. That is just an ordinary constant. We can call it in k or in c, or we call it c. So from here, what do we do? From this point, what do we do? What do we do from this point? So what is u? We change it. Half and u is what? 4 plus y squared. That's what we're going to get. It's equal to n v is equal to what? Tan x plus n c. That's what we are going to get. Okay? That's what we are going to get. I can multiply 2 by 2. This half now, if I want to remove this half, so that I will have n 4 plus y squared will now be equal to 2 n tan x plus, let's say, 2 n c. Okay? That's what we are going to get there. That's what we are going to get there. So, of course, this, n is natural logarithm. This we can come up, so that I will have it to be in tan square x. That is, this can be written as n tan squared x plus, I might start to change everything there. What are there? This can be equal to nc squared. Then I can say let's maybe a or something represent c squared. Okay, in order to be able to write that. Then from there, what do we have? From there, from this point now, no, we have n 4 plus y squared to be that. Okay, that's what we have there. So I can combine the two. So I will say this is n. It's still the same thing. This is n 4 plus y squared to be equal to, I can combine these two now to be n tan squared x plus na. When it's addition, I can change this to a, I can change this to n a tan squared x. That's law of logarithm. That is law of logarithm. So this says as n 4 plus y squared. So when I take the exponential of both sides, exponential will actually cancel out in. Okay? If I take the exponential of both sides, it will cancel out in. So I'm going to have 4 plus y squared to be equal to a tan squared x. That's what I'm going to get. So that's what I'm going to get. Then, of course, I can stop at this point. Or I'll say y squared is equal to a tan squared x minus 4. Where a, a is arbitrarily constant. Okay? So I can stop at this point. So I can just stop my the solution at this point, or I'll just say y is equal to, when I take the square root of both sides, it will be a tan squared x minus 4 raised to the power half. So that's what we are going to get. So when we have first order differential equation, if you are able to rewrite it, then we should know that if you are able to separate it, x to ds, then y to ds, we are expected to apply you are expected to apply separable. That is, we are going to solve such problem with separable variable, and that's what we have seen in these two examples. So I want us to check out what I have here, what I'm about to write. Just attempt this. Attempt these two questions. The first one, solve. The first one, solve s square plus 1 dx plus 1 over y dy equal to 0. Then at y of minus 1 is equal to 1. In this case now, we have condition. So when we solve everything, y of x is what you get. Now substitute for what we have there. Then the second one, the second question that I would love us to attempt is, we have to solve dy dx is equal to y squared plus xy squared all over s squared y minus s squared. So let's attempt these two questions. Then we are going to continue from there, from the comment section. Let's attempt these two questions. So we continue from there, from the comment section. Thank you.